Hey guys, welcome to day 19. Today's topic is induced magnetism, specifically paramagnetism and diamagnetism. All right, let's kind of dig in. This isn't going to take too long, okay? Let me kind of change things up a little bit here. All right, so paramagnetism. Okay, paramagnetism, this is important, is associated with unpaired electrons. Now, this can apply to either atoms or molecules. Now, you haven't done actual electron configurations for molecules yet, and I don't expect you to do that, but you have done them for individual atoms. Okay, and when you do that, you're going to want to kind of do them in arrow form. So we're looking for unpaired electrons. And things that are paramagnetic are weakly attracted to a magnetic field. So I've done the electron configuration for carbon here, and what you'll notice is that it has two unpaired electrons. So all the electrons in 1s and 2s are paired up, but then we get to 2p and we have unpaired electrons. So carbon would be paramagnetic. Carbon would be weakly attracted to a magnetic field because of its unpaired electrons. Okay? But we can also look at molecules, and I don't expect you to be able to do electron configurations for molecules, but we've done these already for you. So we've got some examples here. These are just simple diatomic molecules, so B2, C2, N2, and so forth, okay? And what we're looking here is for unpaired electrons. So boron would be paramagnetic. Boron would be weakly attracted to a magnetic field, and if we dig in a little bit further, we also see oxygen over here. So they obviously do have some electrons that are paired in some of these lower energy levels, but when you start looking around in some of those boxes, you see that there are certainly unpaired electrons. So for boron 2 and oxygen 2, they are going to be paramagnetic. Okay. Now on the flip side, something that is diamagnetic. Okay. Diamagnetic is associated with only paired electrons. So all the electrons are going to be paired up. Okay, and things that are diamagnetic are not going to be attracted, but rather repelled, okay, or pushed away from a magnetic field. So if we dig in a little bit, okay, boron's out and oxygen's out, but take a look at carbon and nitrogen and fluorine and neon. All of their electrons are paired up. So these four substances would be diamagnetic. These four substances would be repelled from a magnetic field. Okay, guys, I really haven't put any new work down here, just some other problems. So when you're doing your homework today, there obviously will be some questions about paramagnetism and diamagnetism, but also go back and brush up on your hybridization. Go back and look at pi bonds and sigma bonds. And some of the questions in today's assignment will be related to those, but there will be a couple related to magnetism. Remember, if you have any questions, you can leave me an email. You can send me a message in Google Classroom. I don't know when I'll see you guys next, but I love you. I miss you. I'll talk to you soon.